Drew's a PhD candidate here, and he completed his undergrad and postgraduate studies in environmental science at Western Sydney University and also then RMIT Uni. He's currently the chair of SETAC Asia Pacific and the Student Advisory Committee. He'll complete his PhD very shortly, and he's going to continue his career in analytical chemistry and environmental science.
Thanks, Brad. Can you hear me okay?
Sure can. And screen's looking good.
Perfect. Well, thanks for the introduction. So today I wanted to share some research that we've completed recently, looking at the concentrations of PFASs at Albert Park Lake, which is actually home to the Australian Grand Prix circuit. And I'm going to show you some pretty convincing evidence that the use of high performance vehicles may be contributing to some really high levels of contamination from this urban lake. So I'd like to acknowledge my co-authors Daniel Moody and my supervisors Raoul Mulder, Mark Green and Brad Clark for their help with this project. Okay, so we know that PFAS are extremely hard to break down, travel long distances in the atmosphere and oceans, and can be toxic in relatively low concentrations. So most of the usual suspects like PFOS and PFOA have been routinely monitored in the environment for around 20 years now, but since their regulation, a new crop of replacement compounds are being increasingly detected in the environment. So one of these compounds is called PFEX. And it's associated mainly with aviation grade hydraulic fluid. It has 8 completely fluorinated carbons and a sulfonate group, just like PFOS, except it's completely cyclic. The acute and chronic toxicological impacts of this compound in humans and wildlife isn't really known yet, but in order to effectively quantify the risk, we need to understand not only the sources, but the transport and bioaccumulation potential. So we're able to measure the transport and bioaccumulation of this compound in swans from Albert Park, and I'll touch on that a little bit in a moment too. So PFEX was first discovered in the Great Lakes in 2011, and it was found to be bioaccumulative in a fish there. Since then, there's been scattered reports of this compound around the Northern Hemisphere, mainly at sites downstream from airports, where it's used as hydraulic fluid. So here you can see the highest concentration reported was downstream of the Beijing International Airport, whilst the lowest concentration reported was from an ice cap in northern Canada. So this shows that the presence of PFEX is associated with long-range atmospheric transport as well. So it's certainly possible for this compound to move long distances in the atmosphere and the oceans, just like PFOS and PFOA. So just quickly about Albert Park, there's no real evidence for legacy PFAS contamination. It was used as a municipal tip up to the 1950s, so we don't really expect there to be any PFAS present in that landfill because, you know, there probably wasn't even PFAS in the country at the time. Then during World War II, it was used by the Australian Defence Force as barracks, but we don't expect there to be any contamination associated with that because there's no aviation usage there either. So finally, the Albert Park circuit was opened in 1996 for the Formula One and other high performance motorsport racing. In 2008, there was actually a stormwater diversion project completed. This was to ensure that the volume of the lake stayed constant throughout the millennial drought. So there's estimated to be about 300 megalitres of stormwater per day diverted to the lake from the surrounding suburbs. And I'll show you a little bit more on that shortly. So we sampled paired water and sediment samples from the 6 sites around the lake, including the water from the stormwater diversion train in the southwest corner of the lake. So we also took around 1 ml of blood from 22 swans at the lake. And while this process is pretty safe and gentle, the birds aren't particularly fond of this process and will defecate on everything. So we were able to get around 50 grams of that excrement from each animal for further analysis as well. The PFAS were extracted by SPE, whilst the sediment and swan excrement samples were extracted by alkaline digestion. in methanol. So all PFAS extracts were analyzed using an Agilent LCM-SMS. So we found the water had quite elevated concentrations of PFAS compared to other surface waters that are nearby. In fact, anyone with some knowledge on typical surface water concentrations may be surprised looking at the total PFAS concentrations in this lake. We certainly were. The three most abundant compounds here were PFOA with an average concentration of 47 nanograms per litre, PFOS at 31 nanograms per litre, and PFHXS at 12 nanograms per litre. So one site even had 150 nanograms of PFOS per litre, which exceeds the Australian guideline for the 95% species conservation. Now, these concentrations are consistent more with surface water impacted by wastewater, industrial or agricultural inputs, rather than the typical surface water concentrations you'd expect. Furthermore, the cyclic compound PFEX was detected in all water samples at average concentrations of 27 nanograms per litre. So this is in the same range as surface waters adjacent to airports in North America and Asia. So concentrations of PFAS this high and the presence of PFEX were really unexpected. And you'll notice that there wasn't any PFEX detected in the water coming from the stormwater drain. And in fact, the total PFAS concentrations from the stormwater were much lower as well. We also found elevated concentrations of primarily long-chain PFAS in the sediment paired to the locations of the water samples. And this followed the expected water sediment distribution patterns that have been reported in the literature. So there is an increasing affinity for PFAS to sediment with increasing chain length, right? So the higher number here means that the compound is more likely to absorb to the sediment fraction. And this is driven primarily by the organic carbon fraction and also the hydrophobic absorption to the surface of the particles. So we calculated the distribution of PFEX and found it to be slightly lower to that of its aliphatic companion PFOS, which means that it won't strongly sorb to sediment and will be dissolved in the water. There's currently little known about the fate of PFEX in the environment so far. So this measurement will be important for developing models that are used to inform risk assessments. But we can essentially think about PFEX behaving similarly to PFOS and PFOA with respect to its water sediment distribution. So the question is, where is all this PFAS coming from? So we've excluded the historic contamination of PFAS to the lake from legacy landfill and the Australian Defence Force. And it is possible for some of the contamination to be coming from the stormwater drain. But here you can see a map of the catchment that's actually diverted to Albert Park Lake. And we know that this is predominantly residential area with some mixed commercial zoning, which is just convenience stores and cafes, that kind of thing. There's no industrial sources to this area that would explain the high levels of contamination that we're observing. And nothing in this catchment would explain the presence of PFEX, which is only used, as far as we can tell, in aviation grade hydraulic fluid. So we're left with one more explanation, the use of high performance vehicles at Albert Park Circuit. So we're proposing that these vehicles may be using high performance hydraulic fluid as, in the vehicles, and this has somehow made its way into the environment. There is also a possibility that legacy AFFF storage on the site could also have caused some of the contamination that we're seeing. But PFEX isn't really strongly associated with AFFF exposure as far as we know. But we're certainly going to be following up with these conclusions in the future. But if our suspicions are true, then there was going to be huge international implications for human and ecological health. There's many similar circuits around the world, and many of them are in densely populated areas too. So, some of those locations might even rely on the nearby surface water or groundwater, leading to human or ecological exposure. And I think I've run out of time, but just really quickly, I wanted to just touch on some of the relationships we found between PFOS concentrations in serum and excrement. And there's a number of compounds that we can see in both, which leads us to believe that we might be able to use excrement in the future to determine the body burden of PFAS in swans from this area too. And with that, I'm going to wrap that up, and thanks very much.